Number 6. Construct the Lewis model for the covalent compound methylene chloride. Okay, so the number of valence electrons in the carbon. Carbon is in group 4. So there are 4 valence electrons in carbon. And then the total number of valence electrons in the 2 hydrogens going to be 2. And then the chlorine is in group 7. 7 times 2, 14. So the total number of electrons are going to be then 20. Position the atomic core for carbon as a central atom, and then the other cores around it. So there we can have 2 hydrogens, and then the chlorine, and then put pair of electrons between them. Carbon, chlorine, hydrogen, chlorine. Okay. And we used from the 20 electrons, now we put 8 dots. So 20 minus 8, 12. So these 12 electrons we give to the chlorine to make them an octet. So we put 6 there. We can do this in the next diagram. Write the Lewis structure. So when you write the Lewis structure, you can do it over here. Carbon, chlorine, hydrogen, and then the 12 electrons you put as lone pairs on chlorine. I just drew it outside the box. That's the Lewis structure for CH2Cl2. Construct the Lewis structure model for the covalent compound carbon tetrachloride. Same thing, the total number of valence electrons. So carbon, group number 4, valence electrons 4. There are 4 chlorines. Each chlorine is 7. So 7 times 4, 28, plus 4, 32. So there are 32 valence electrons. Write the atomic core for the element that seems most likely to be the central atom in the molecule in the space. Position the remaining atomic cores around it. So you put carbon in the center, and then you have 4 chlorines. Chlorine, and then put electron pair between each of the bonding atoms. C, Cl, 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 Cl. Now out of the 32 valence electrons, we have used up 8 for the bonding. So how many more left? How many more left now? You are left with 24 electrons, right? Now we're going to distribute these 24 electrons on the terminal atoms, giving each of them an octet. Since I don't have enough space in the box, I'm going to write it outside. I can put carbon center, chlorine, and then 24 electrons are left. So I'm going to give them as lone pairs to chlorine. 6, 12, 18, 24. So we distributed all the valence electrons. So chlorine is happy having 8 electrons. 8, 8, 8. And then the carbon also happy having its 8 electrons. Everybody is happy with the octet. Okay. And then the next one, construct the Lewis structure model for the covalent compound phosgene using the following steps. The total number of valence electrons COCl2. So there are 3 types of atoms here. Carbon, group number 4, valence electrons 4. Oxygen, group number 6, valence electrons 6. There are 2 chlorides, so each chlorine is 7. 7 times 2, 14. So 14 plus 6, 20, so 24. There are 24 valence electrons in COCl2. Right? And then, what's the next step? In this compound, carbon is the central atom. Arrange the atomic course appropriately in the space below. So we're going to put carbon in the center, Cl, Cl, oxygen. Add a pair of electrons, C, O, Cl, Cl. Now we had 24 valence electrons, so we used up 6 electrons. We had 24 valence electrons, we used 6 for the bonding and 18 left. Now we're going to distribute this 18 in the terminal atoms to give each an octet. Okay, let's do that. 2, 4, 6, 8, 10, 12, 14, 16, 18. So we give now all the peripheral atoms, terminal atoms. They are happy with an octet, 8 electrons. What about the carbon? Carbon now only have 2, 4, 6 electrons, the blue 6 ones. So what's going to happen when the carbon is now electron deficient? Oxygen is going to give 2 electrons from its lone pairs to make a double bond. So let's say you take one of these lone pairs and then make a double bond right there, carbon, carbon here. So carbon already had a lone pair and then oxygen give that lone pair, so making it a double bond. So then the Lewis structure would look like this. Between carbon and oxygen you will have a double bond. Between carbon and chlorine, a single bond like this. So now carbon happy having 8 electrons, oxygen happy having 8, everybody's happy. Okay, and this is going to be 8 shared electrons for carbon, 8 for chlorine, 8 for chlorine, and 8 for oxygen. That's the COCl2. And then the next one, construct the Lewis structure model for the covalent compound silicon dioxide, SiO2, using the following steps. The total number of valence electrons in SiO2. Again, the silicon is in the group 4. So silicon group number 4. So 4 plus oxygen is in group 6. So there are 2 oxygen atoms, 6 times 2, 12. So 12 plus 4 is going to be 16. So there are 16 valence electrons. Arrange the atomic course appropriately. Arrange the atomic course appropriately. Write the Lewis structure for SiO2 in the box. Use the electron pairs to show the bonds between the atoms. Okay, the same procedure that we did, we're going to follow and do the Lewis structure. SiO2. So you put Si in the middle, 2 oxygens, put a lone pair, not lone pair, bonding pair between these. So there are 6 electrons. So we used 4. So there are 12 left. That 12 you're going to put between 2 oxygen. You're going to distribute them. Oxygen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right now you distributed all 16. But see, oxygen is happy having 8 electrons. But is silicon happy yet? Silicon has only 4 valence, 4 shared electrons. This is what we have right now for silicon. So what's going to happen is, since it's 4, we want to make it 8. Oxygen will give 2 electrons to make it double bonds. So oxygen, take this lone pair and give to this silicon to form a double bond. Similarly, the other oxygen will lose 1 lone pair and give those 2 electrons to form a double bond. Okay, now silicon has 8 electrons and oxygen also has 8 electrons. 2, 4, 6, 8. This is for oxygen and this is for oxygen. 2. There are 2 double bonds. Right, so there are if you draw the structure, it would be look like this with the bonds. Okay, 2 double bonds. So the number of double bonds are going to be 2. Write the Lewis structure for hydrosulfide ion, HS minus. The total number of valence electrons in HS minus. So for the hydrogen, group number 1, sulfur is group 6, right? And then HS minus, it has a negative charge. How does an element become, or a compound or an ion become negative? By gaining an electron. So since it is only 1 negative charge to the number of valence electrons, you have to add 1 electron. So remember, all of these are electrons that we are adding. So then the number of valence electron would become 8. Okay, and then the Lewis structure for HS minus would be then hydrogen, sulfur. So put 2 electrons between hydrogen and sulfur, 6 left, and then you put that 6 electrons on sulfur, giving sulfur an 8. And since this is a charge ion, so you put the negative 1 on the side, negative 1. Okay, and then the Lewis structure for the nitrogen. Nitrogen, you can see nitrogen is in group 5. So there are 2 nitrogens. So group 5, 2 times 5 is 10 electrons. So we're going to distribute these 10 electrons between 2 nitrogen atoms to draw the Lewis structure. So nitrogen, nitrogen. You put 2 electrons between the 2 nitrogen. Remember, we had 10 electrons. So you distribute 2, 4, 6, 8, 10. So now we have all 10. But if you look at this structure, our goal is to have everybody an 8. Right now each nitrogen has 2, 4, 6. This nitrogen has 6. This nitrogen also has 6. We want to make them 8. So how can we make them 8? You take one of the lone pairs of the nitrogens and then make it a double bond like that. By doing that, the nitrogen on the left has 2, 4, 6. Nitrogen on the right has 2, 4, 6, 8. Right, 8 electrons. But the left one is still crying. So what's going to happen is you take one of these lone pairs and then make another bonding pair between nitrogen. Now if you count, each nitrogen has 8 electrons. So that would be the Lewis symbol for nitrogen. Nitrogen, between two nitrogen atoms, there is a triple bond like this. The number of valence electrons in nitrogen is 10, and there is a triple bond between the two nitrogen atoms. Writing chemical equations using Lewis structures for reactants and products. Okay, let's see. Complete the following table. Assume that the first two pairs of elements react to form ionic compounds. Okay, so let's see. Number of valence electrons in potassium, that is 1. Iodine has 7 valence electrons. So the empirical formula would be potassium with 1 electron, iodine 7 electrons, 1, 2, 3, 4, 5, 6, 7. And then the Lewis structure of the product would be, since it's ionic compound, potassium will lose that 1 electrons, and then iodine will take that electron. So this would become, by losing that electron, K plus. And then the iodine will take that electron from potassium. This would become minus 1. Potassium iodide. And then the next one, calcium, number of valence electrons. Calcium is in group 2, so 2. And then the fluorine, number of valence electron. If you take 1 fluorine, it would be 7. But if you're going to use 2 fluorines, it's going to be 14. So the calcium would be with 2 electrons, and then the fluorine would be diatomic molecule. Since there are 2 valence electrons for calcium, it needs 2 fluorine atoms, and we can use this diatomic molecule. This is the Lewis structure for fluorine, like this. These two combine to give you the Lewis structure. 1 calcium, calcium 2 plus, and then the fluorine would be making it 2 fluoride ions, 2F minus. One calcium and 2 fluoride ions. Those are the Lewis structures for the 2 ionic compounds. And then the sulfur and the chlorine, I'm going to go ahead and erase this since I don't have space. And then the sulfur and the chlorine, number of valence electrons. Sulfur is in group 6. And then the chlorine again, each chlorine is 7. And then with 2 chlorine, it would become 14. So the empirical formula, since sulfur is 6, it needs 2 chlorine atoms to make it an octet. So sulfur would be in the center, the 2 chlorine atoms. And then the Lewis structure would be or you can also write it like this, separate. Sulfur would be 6. 1, 2, 3, 4, 5, 6. And then the chlorine, diatomic molecule like this, sulfur and the chlorine together. And then the Lewis structure would be sulfur in the center, chlorine, chlorine, two lone pairs, the others going to form like this. That is the Lewis structure of the product, SCl2, sulfur chloride, SCl2. Okay. Okay. Do we have something else? Yes. Oh. Okay, over here. So silicon atoms and chlorine molecules. So you have to write a reaction, how it's going to form. So the silicon atom, silicon is in group 4. There would be 1, 2, 3, 4. And then the chlorine molecules. So it needs 2 chlorine molecules. So the chlorine exists like a diatomic molecule, like this. Okay. Now, since there are 4 electrons surrounding silicon, you need 2 chlorine molecules. And this would combine to give you chlorine, 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 1, 2, 3, 4, 5, 6, 7. Don't have space, but you understand what I'm doing over here. Each chlorine has 7 electrons. It pairs up with the silicon electrons to give you SiCl4. So silicon plus 2 chlorine give you SiCl4. Okay. Next one, lithium atoms and bromine molecules. Lithium atoms and bromine molecules. So the lithium has 1 electron being in group 1, and then the bromine is this. Lithium bromide. And then plus LiBr. So we want lithium since there are 2 bromide ions in a bromine molecule, we can use 2 lithium ions, 2 lithium plus 1s, and then bromide. We can put this outside. That's going to be Br minus. It's going to form 2 lithium bromide compounds. And then the next one, ethylene molecule and chlorine molecules. The product is C2H4Cl2. So we're going to write the equation for this one, C2H4. So when you write the Lewis symbol for C2H4, it would be something like this. There are 2 carbons and then the hydrogens. I'm going to go ahead and draw the electrons. And then you will see there is a double bond between the 2 carbons when you draw the Lewis structure. Okay. and this is going to react with chlorine. Chlorine going to be like this. And then together, now the chlorine, two chlorine atoms, chloride atoms are going to attach to the two carbon. It's going to form C2H4Cl2. CCH4Cl2, chlorine, chlorine. Now this is going to be your product. Chlorine has, both chlorides have 8 electrons, carbon has 8, hydrogen has a duet. Okay. And then the next one, the empirical formula for the hydride of sulfur is H2S. And then what would be the empirical formula of hydride of selenium? So sulfur and selenium, they are on the same group, group 6. If it form H2S and selenium is also in the same group, so then the empirical formula should be H2SE. And then the Lewis structure. So the selenium has 6 valence electrons, 2 hydrogens, 2 valence electrons. Selenium has 6, so 8 valence electrons. So selenium going to be in the center, hydrogen would be on the side, just one pair between the atoms, and then the remaining 4 you put on selenium to give it an octet. That's the Lewis structure for hydride of selenium. And then SiH4, silicon and hydrogen, SiH4. What is the empirical formula for hydride of tin? So silicon and tin, symbol Sn, Si and Sn, they are both on group 4. So SiH4, then Sn also need to be H4. So tin, valence electrons 4, hydrogen 4, 8. So tin SiH4 would be like this Lewis structure. There are 4 hydrogens. Okay, that's the Lewis structure for hydride of tin. Okay, so it's a little bit long one, but with this you have some practice as to how to write the Lewis structures. Okay, and we're gonna elaborate on this even more in general chemistry 1. Okay, with the lecture and the labs. All right, then I'll stop here and I'll talk to you in the next video. Bye bye.